Hi, in this video we're going to solve Pure Maths 3 past paper from May-June 2022 series. Let's have a look at the first question. Okay, so that's a very standard one. We have a inequality with modulus sign, and we have a very standard technique for this. We have to square both sides, and then we have to solve the resulting quadratic inequality. So let's get started. First of all, square both sides, and we get 4 times 3x plus a squared less than 2x plus 3a squared. Okay, so let's square the brackets, and we'll get 9x squared plus 6xa plus a squared less than 4x squared plus 12ax plus 9a squared. Okay, expand the bracket on the left, and we'll get 36x squared plus 24ax plus 4a squared less than, I'll just copy what I've got on the right side. And then I'm going to move everything to the left side, and I will get 32x squared plus 12ax minus 5a squared less than 0. Okay, and to solve the quadratic inequality, I will first draw a very rough sketch. So that's the quadratic function, of course, and it opens up because 32, the coefficient of x squared, is positive. So it's going to look like that, and we're looking for all the values that are less than 0. So that means we're looking for all the values of x for which the curve is below x-axis. So it's going to be in between x1 and x2. Okay, and now we have to determine what are the values of x1 and x2. And in order to do so, we'll have to solve the quadratic equation instead of an inequality. And to do so, I'm going to use a quadratic formula. In our case, a is equal to 32, b is going to be 12a, and c equals to minus 5a squared. And then when I substitute it into quadratic formula, I will get minus 12a plus or minus the square root of 144a squared plus 640a squared. And all of this over to a, which is 64. Okay, now we're going to simplify the expression under the square root. 144 plus 640 is going to be 784 a squared over still 64. Now we can take the square root. The square root of 784 is 28. Square root of a squared is a over 64. Now in this formula, if I take the minus sign, I will get minus 40a over 64. And when I simplify it, I will get minus 5a over 8. And then in the quadratic formula, when I take the positive sign, I will get 16a over 64. Which gives us a over 4. Okay, so these are the values of x1 and x2 in the sketch. We're looking for all the values that are less than 0. So that means x is in between minus 5a over 8 and a over 4. I will state this as the answer for the first question. For the second question, first of all, I'm going to use the formula cos a minus b equals to cos a cos b plus sin a sin b. Okay, so that brings us to cosine theta cosine 60 plus sin theta sin 60 equals to the right side, which is 3 sine theta. And we know what the values of cosine 60 and sine 60 are. So cos 60 is 1 over 2, and sine 60 is root 3 over 2. Okay, I'm going to substitute this into the equation. So I'll get cosine theta over 2 plus square root of 3 times sine theta over 2 equals to 3 sine theta. Okay, now in this equation I have sine and cosine at the same time. That's not really good. So what I can do is to divide both sides by sine theta, or even better by cosine theta. So I can get tangent. And I will get 1 over 2 plus square root of 3 over 2 tangent theta equals to 3 tan theta. Okay, and now I will collect all tangents on the right side of the equation. So 3 times tan theta minus square root of 3 over 2 tan theta. Next, I want to make tan theta kind of the subject of the formula. So first I will factorize, bring tangent outside, and then divide both sides by the bracket. So I will get tangent theta equals to 1 over 2 divided by the bracket. Okay, and next I can simply take the inverse tangent of both sides, and I will get theta 1 equals to 13.2 degrees, and to get the second value, I can add 180 to the first one, and I will get 193.2, and both answers are within the range, which is from 0 to 360. Okay, so basically what it says is to get rid of logs, and in order to do so, I'm going to transform this equation in the form log A equals to log B. And then from here, that means A equals to B, and then I can probably rearrange this equation. Okay, so first off, I'm going to move all logs on one side. So I will get log base 3 2x plus 1 minus 2 log base 3 of x minus 1 equals to 1. And now I'm going to use a few laws of logs. So first of all, I'm bring the number in front of the log to the power. That is log base 3x minus 1 squared equals to 1. Now, when I'm subtracting the logs, that's going to be a log of a fraction, which in this case is 2x plus 1 over x minus 1 squared equals to 1. Now, remember, our goal is to write the equation in the form log A equals to log B. Now, that means I will have to transform 1 into log. I can say that log base 3 of 3 equals to 1. So that means I'm going to replace 1 with log base 3 of 3. And I will get this. And now we've achieved our goal, log A equals to log B. So it means I can just remove the logs and say 2x plus 1 over x minus 1 squared equals to 3. And now I can rearrange this equation. So multiply everything by x minus 1 squared to get 2x plus 1 equals to 3 times x minus 1 squared. Now from here I'm going to just square the bracket. X squared minus 2x plus 1 multiplied by 3. So 2x plus 1 equals to 3x squared minus 6x plus 3. And now I rearrange this equation and I will get 3x squared minus 8x plus 2 equals to 0. Now, if you look at part B, you can see that these equations are really similar, apart from the fact that x equals to 2y. So we can actually use part A in order to solve part B. So I will say x equals to 2y, and next I will solve the equation from the part A, and say that the answer equals to 2y, and then divide by 2 in order to find y. Okay, so let's get started. We got 3x squared minus 8x plus 2 equals to 0, and we can use the quadratic formula to get 8 plus or minus 64 minus 24 over 6, which is 8 plus or minus the square root of 40 divided by 6. Okay, now if I take this with a positive sign, I will get 2.387. If I take it with the minus sign, I will get 0.279. Now, I will have to divide both values by 2, because x equals to 2y. So first, 2y equals to 2.387, or 2y equals to 0.279. Okay, divide by 2, and we'll get y1 equals to 1.19, and y2 equals to 0.139. Okay, but now, don't forget that we're actually not solving just a quadratic equation. We are solving equation with logarithms. And this kind of has some restrictions on our answer. The thing is that the expression under the log should never be negative, because you can't take the log of a negative number. So we have to make sure that our answers don't make expression under log negative. And the thing is that y2 equals to 0.139 will make 2y minus 1 less than 0, so we don't include this in the final answer. So my answer is going to be only 1.19. Okay, next question is about differentiation, and we have to find the derivative of e to the power of minus 4x times tangent x. Because that's a product, I'm going to use the product rule, which is u times v derivative equals to u derivative v plus v derivative u. Okay, so let's get started. Y derivative equals to derivative of e to the power of minus 4x is going to be, I'm using the chain rule, e to the power of minus 4x times derivative of the inside function, which is minus 4x, and when I take the derivative, that gives us minus 4 times v, which is tangent x, okay, plus v derivative. So derivative of tangent is secant squared x times u, which is e to the power of minus 4x. Okay, so technically we're done with the derivative, but we have to write it in this form, secant squared x times the bracket and times e to the power of minus 4x. So first of all, we can factorize and bring e to the power of minus 4x out of the bracket. So we get minus 4 times tangent x plus secant squared x. Okay, and also if we look at this form, secant squared x should be outside of the bracket, so let's also bring it outside, and we'll get e to the power of minus 4x times secant squared x. Now, in the bracket, we've got minus 4 tangent x over secant squared x. Now, because secant squared is outside, here we've got plus 1. Okay, so now let's have a look at tangent x over secant squared x. I'm going to first write tangent x as sine x over cosine x. then I'll have to divide it by secant squared x, which is actually 1 over cosine squared x. Now, what we have to do is to flip the second fraction over, so we get cosine squared x over 1, and we can simplify this fraction, cancel out cosine x, and we've got sine x, cosine x. Now, let's have a look again at the form they're asking for. So they're asking us to have sine 2x. And we have something similar to that, because the formula for the double angle for the cosine, for the sine, is going to be sine 2x equals to 2 times sine x cosine x. And it's kind of very similar to what we've got here, apart from the 2. So I'm just going to write 2 in here, but in order not to change anything, I'll divide by 2. And that brings us to sine 2x over 2. Okay, and now I can replace tangent x over secant squared x with sine 2x over 2. Let's do that. So secant squared should go first. And then goes the bracket. I've got 1 minus 4 sine 2x over 2. And don't forget to multiply by e to the power of minus 4x. And we almost got the answer. Okay, that's it. Okay, next one is about finding x coordinate of two stationary points. And in order to do so, we'll have to make derivative equals to 0. We already have a derivative from the previous question. So let's use it and say that secant squared x times the bracket minus 2 sine 2x plus 1 times e to the power of minus 4x equals to 0. Okay, so we have the product of three things, which equals to 0. That means either of the factors can be equal to 0. So we could say either secant squared x equals to 0, or the bracket equals to 0, or e to the power of minus 4x equals to 0. Okay, let's start with the first one. Secant squared is 1 over cosine squared x equals to 0. And there is no way you can divide 1 by anything and get 0 as a result, so that means this equation has no solutions. Now let's have a look at e to the power of minus 4x equals to 0. Also, you cannot raise any number to some power and get 0 as a result, so that means this equation has no solution also. Okay, so one in the middle. Let's just rearrange it, and that will be minus 2 times sine 2x equals to minus 1. Divide both sides by minus 2, and we'll get sine 2x equals to a half. Now at this point, let's take the inverse sine of a half, and we'll get 2x equals to pi over 6. And then very important, at this step, don't forget about the second value. 2x equals to pi over 1 minus the first value, which is pi over 6. So that gives us to 5 pi over 6. Okay, and now all we have to do is to divide both of them by 2, and we'll get x equals to pi over 12. That's the first one. And the second one would be 5 pi over 12. That's going to be our final answer for that question. Pi over 12 and 5 pi over 12. All right, complex numbers. So u equals to 3 minus I. Okay, that's going to be point A. Point B is the complex conjugate. And to find it, all you have to do is to switch the sign of the imaginary part to the opposite. So instead of minus I will have 3 plus I. And the number c is going to be the complex conjugate minus the number itself. Let's figure it out. 3 plus I minus, don't forget the brackets, 3 minus I, which equals to 2I. Okay, show on the Argand diagram those points. Okay, the sketch. The horizontal axis is going to be the real part, y-axis is imaginary. Okay, let's start with the point C. It's 2I, 1, 2, this is point C. Point A is 3 minus I, so it's 1, 2, 3, and one step down, like that. So this is point A, and point B is 3 plus I. It is here. And also we have the point O. Now we have to state the type of a quadrilateral formed by the points O, A, B, and C. Let's draw this quadrilateral. And we can clearly see that this quadrilateral is a parallelogram. Express u conjugate over u in the form x plus I, y. Okay, sure. Let's have a look at what u and u conjugate are and write it down. U conjugate over u equals to 3 plus I over 3 minus I. And to get this into the form of x plus iy, which is actually called a Cartesian form, there is a very standard technique. All we have to do is to multiply the top and bottom of the fraction by the complex conjugate of the denominator. So it's going to be 3 plus I squared over 3 minus I times 3 plus I, which is the complex conjugate. Now, all I have to do is to multiply it out, which is 9 plus 6I plus I squared, which is actually minus 1, over. Let's expand those brackets, and I'm using the formula a minus b times a plus b equals to a squared minus b squared. So I will get 9 minus I squared. So that gives me plus 1. So all in all, I've got 8 plus 6I over 10. Let's split it into two parts and simplify both of them. So 4 over 5 plus 3 over 5i. That's the answer. In the next question, I'll have to prove this identity, and I think I will take the otherwise path, just because I want to be a little bit more creative with this exam. Okay, so what I have to do is to show that the inverse tangent of 3 over 4 equals to 2 times something. That something has to be determined. I'm going to call this b. And I got the equation, and what I'm going to do now is to take tangent of both sides. So I'll get tangent of the inverse tangent of 3 over 4 equals to tangent 2b. Now at this point, on the left side, tangent and the inverse tangent will cancel out, and I'll get 3 over 4 equals to tangent 2b. Now remember, my goal is to determine what b is. Okay, here I'm going to use the formula for the double angle for the tangent. So 3 over 4 equals to 2 tangent b over 1 minus tangent squared b. I'm going to multiply both sides by the common denominator, and I will get 3 times 1 minus tangent squared b equals to 4 times 2, which is 8, tangent b. Now, I will rearrange this and I will get a quadratic equation. And now I can solve this and find what tangent b is. So tangent b equals, I'm going to use the quadratic formula and get minus 8 plus or minus square root of b squared minus 4ac, which in that case is going to be 64, plus 36 over 2a, which is 6. Just a couple of more rearrangements. Minus 8 plus or minus 64 plus 36 is going to be 100, square root 10 over 6, plus and minus, and I will get 1 over 3 or negative 3. Okay, so that means tangent b equals to either 1 over 3 or tangent b equals to negative 3. Now, let's have a look at the beginning of the question. I was going to find out what b is in such a way that the inverse tangent of 3 over 4 equals to 2 times b. Okay, now the inverse tangent of 3 over 4 is positive, and so is 2. So that means b must be positive. Now let's have a look at my options. So the first one is tangent b equals to 1 over 3, so that means b equals to the inverse tangent of a third, which is actually positive, or the second option is b equals to the inverse tangent of negative 3, which is negative. So that means I will have to choose the first option and say that b equals to inverse tangent of 1 over 3. And now, if we look back at our first line, that means inverse tangent of 3 over 4 equals to 2 times b, which is inverse tangent of a third. So that means I've proven what I had to prove. So I'm going to write, therefore, inverse tangent of 3 over 4 equals to 2 times b, which is inverse tangent of a third. Proven. Okay, next one is about parametric differentiation. We have x and y in terms of t, and we have to find dy over dx. Okay, so first of all, dy over dx is going to be, well, since I have x and y in terms of t, I can find dy over dt. Now, in order to get dy over dx, I will have to multiply it by dt over dx. And now I can find dy over dt and dx over dt separately, and then substitute this into that formula. So let's start with dy over dt. So y equals to natural log of tangent t. That means I will have to use the chain rule. Okay, so the derivative is 1 over tangent t times the derivative of the inside function, which is tangent t. That gives us 1 over tangent t times the derivative of a tangent is secant squared t. And we get 1 over tangent t, and I will write secant squared t as 1 over cosine squared t. Okay, now it's time to move to dx over dt. I'm going to write 1 over cosine t as cosine t to the power of -1. And then I'll have to take the derivative. Again, that's the chain rule. Derivative of the outside function is going to be -1 times cosine t to the power of -2 times derivative of the inside function, and that is minus sine t. Let's simplify that a little bit. Minus and minus will give us plus. So all in all, we've got sine t over cosine squared. Okay, and now it's time to substitute all of that into dy over dx. So dy over dx equals to dy over dt, which is 1 over tangent t cosine squared t, then multiplied by, we have to do dt over dx, and we've got the expression for dx over dt. So what I'm going to do is to flip this fraction over, and I get cosine squared t over sine t. Now cosine squared and cosine squared will cancel out, and I've got 1 over tangent t times sine t. But that's not quite what the question is asking for. We shouldn't have tangent. So I'll replace tangent with sine over cosine. We've got 1 over sine t. Now cosine t will go to the top of the fraction. And then sine t remains at the bottom. And all in all, we've got cosine t over sine squared t, which is exactly what we had to show. Let's have a look at the next one. Next question, we'll have to find the tangent to the curve. And we know that the equation of any line, including the tangent, looks like y equals to mx plus c, where m is the gradient, and in this case, the gradient is going to be given by the derivative at the point of intersection. I'm going to call the point of intersection as P. Now, normally, when we're looking for the value of c, we'll have to substitute the point P into the equation and just rearrange it and find the value of c. So we'll have to substitute the point P. Okay, so all in all, it looks like we'll have to find the coordinates of the point P, the point of intersection of the curve, and the tangent. Okay, so how can we find it? We know that the point of intersection is where y equals to 0. Now, let's have a look at the question, and we actually have the equation for y. It is log of tangent t. So that means log of tangent must be equal to 0. And I will have to solve this equation. Okay, now I'm going to raise e to the power of the left side and the power of the right side. Now e to the power of the log, that will just cancel out. So I'll get tangent t equals to e to the power of 0, which is 1. So that means tangent t equals to 1. And from here, I can find the value of t, which is the inverse tangent of 1. So t equals to pi over 4. Now, what about the x and y coordinates of t? Again, let's have a look at the question. We have the formula for x and y coordinates. X equals to 1 over cosine t. So from here, x equals to 1 over cosine pi over 4. So it's 1 over square root of 2 over 2. And that gives us 2 over square root of 2, which is just the square root of 2. So now we have the x and y coordinates of the point, which is square root of 2 and 0. And we also know that for this point, the value of t is pi over 4. Okay, so now we can substitute all of this into first the derivative in order to find the gradient of the tangent line. So y derivative of pi over 4. We already have the formula for that. Cosine t over sine squared t. So let's substitute it and we'll get square root of 2 over 2 divided by square root of 2 over 2 squared, which gives us just square root of 2. So now y equals to square root of 2x plus c, and according to our plan, we have to substitute the point P into this equation in order to find c. So x equals to square root of 2 and y equals to 0, so it means 0 equals to square root of 2 times square root of 2 plus c, and then therefore c equals to minus 2. And we have our equation, which is y equals to square root of 2x minus 2. And I will say that this is going to be the answer for that question. Next question is about partial fractions. And before we start, we have to make sure that the maximum power in the numerator is less than the power of the denominator. So the highest power of the numerator is 2. And the highest power of the denominator, when you multiply x by 2x squared, you will get x to the power of 3. So yes, the power of the numerator is 2, the power of the denominator is 3. So that means we can continue to our partial fractions. Okay, let's just rewrite the question. 5x squared plus 8x minus 3 over x minus 2, which is a linear factor. And then we have 2x squared plus 3, and we call it a unfactorizable quadratics. So the first one, the linear factor, will give us a partial fraction in the form of a over x minus 2. And the second one, unfactorizable quadratics, will give us a factor, a partial fraction in the form of bx plus c over 2x squared plus 3. Okay, so now we try to combine the two fractions back into the single one, and we'll get a times 2x squared plus 3 plus bx plus c times x minus 2 over the denominator. Okay, so now at this step, we're just going to compare only the numerators of the two fractions. So basically, we're looking for the values of a, b, and c, such as 5x squared plus 8x minus 3 would be equal to a times 2x squared plus 3 plus bx plus c times x minus 2. And it should be equal for all values of x. So that means I can substitute whatever x I find convenient. So for example, first of all, I'm going to substitute x equals to 2. That gives me an opportunity to cancel out this bracket, because we have x minus 2. So when I substitute it on the left side, I will get 33 equals to a times 11. And that means a equals to 3. Okay, now I'm going to substitute x equals to 0 because I want to cancel out b. So when I do this, I will get minus 3 on the left side, and then on the right side, I will get 3a minus 2c. And I already know that a equals to 3, so that gives us equation minus 3 equals to 9 minus 2c, and we can solve it for c. then we'll get c equals to 6. Okay, and next I can substitute just any number. I will say just, okay, x equals to 1. Quite easy to substitute. So we get 10 equals to 5a plus b plus c times minus 1. And we already know what a and c are. So we substitute it there, and we'll get 10 equals to 15 minus b plus 6, which is c, and we can solve it for b. So 10 equals to 15 minus b minus 6, and from here we get minus b equals to 1, therefore b equals to minus 1. And all in all, our answer is going to look like 3 over x minus 2 plus minus x plus 6 over 2x squared plus 3. Or maybe I can just make it look a little bit better and say it's going to be 3 over x minus 2 minus x minus 6 over 2x squared plus 3. I will keep this as the final answer. The next question is about generalized binomial expansion, when you have to use the formula 1 plus x to the power of n equals to this large expansion, and it's probably the most tedious question in this exam, where Cambridge is actually testing your algebraic skills. So first of all, let's start with the first fraction, and let's try to expand 1 over x minus 2. I'm going to write it as in the form minus 1 over 2 minus x. So I'm trying to get it in the form 1 plus x to the power of n. A couple of more steps. It's going to be minus 1 over 2 times factorizing. So 1 minus x over 2, which equals to minus 1 over 2 times 1 plus minus x over 2, then to the power of minus 1. Okay, so now we've reached the form where we can use the formula, and we're going to get minus 1 over 2 times 1 minus 1 times minus x over 2 plus n times n minus 1 will give us minus 1 times minus 2 over 2 factorial, which is 2, times x squared, which in this case is going to be x squared over 4. And we don't have to use the formula any further, because we're only looking for the terms up to x squared. So let's just simplify this a little bit, and we'll get minus 1 over 2 times 1 plus x over 2 plus x squared over 4, and we get minus half minus x over 4 minus x squared over 8. And now let's have a look at this second fraction. Now I'm going to focus only on 1 over 2x squared plus 3. So 1 over 2x squared plus 3 equals to 1 over, let me just rewrite it. I'm going to factor out 3. So I get 1 plus 2x squared over 3. That equals to a third times the bracket 1 plus 2x squared over 3 to the power of minus 1. And now we're ready to use the formula, which will give us a third times 1 minus 1 times 2x squared over 3 plus n minus 1 over 2 times 4x to the power 4 divided by 9. And actually there is no need for this term because we're only looking for the expansion up to and including x to the power 4, so there's no need for that. Okay, so now all in all we are ready to combine all our results together. We'll get 3 times bracket minus a half minus x over 4 minus x squared over 8. That's our first expansion. Okay, so now minus x minus 6 over 3. Now I'm trying to combine the second one. And I get 1 minus 2x squared divided by 3. Now all we have to do is to expand the brackets and simplify. So, all in all, I will get minus 3 over 2 minus 3x over 4 minus 3x squared divided by 8. Okay, then minus a third. And then I'm multiplying the brackets x minus 6 times 1 minus 2x squared over 3. So I'll get x minus 2x cubed over 3 minus 6 plus 4x squared. Which gives us minus 3 over 2 minus 3x over 4, 3x squared over 8, and then multiplied by minus a third. So we get minus x over 3 plus 2x cubed over 9 plus 2 minus 4x squared divided by 3. And finally we get the answer, which is a half minus 13 over 12x minus 41 over 24 x squared. That's it. The next question is about differential equations. So first of all, let's write it down. dn over dt equals to k n to the power 3 over 2 cosine 0.02 t. And we also know that when t equals to 0, n equals to 100. Okay, so first of all, let's separate the variables, and let's say dn equals to k n to the power 3 over 2 cosine 0.02 t times dt. Now, at this point, we have dn on the left and n on the right side. That's not good, so let's divide both sides by n to the power of 3 over 2. And we'll get n to the power of minus 3 over 2 dn equals to k times cosine 0.02 t dt. And now at this point, the variables are separated. We have n and dn on the left and t and dt on the right. So that means we'll have to integrate both sides. And we will get minus 2 to the power of n minus a half equals to k integral of cosine is going to be sine 0.02 t divided by 0.02, and don't forget to add c. Now, at this point, we'll have to figure out the value of t, or the value of c, and we can substitute t equals to 0 and n equals to 100. So we'll get minus 2 over 10 equals to c. So that means c equals to minus 0.2. And we also calculate that 1 over 0.02 is going to be 50. So our equation is going to be minus 2 over square root of n equals to 50 k times sine 0.02 t minus 0.2. And I will leave this as my final answer. Now for the next one, we'll have to find out the value of k, given that n equals to 625 and t equals to 50. So we can substitute both of the values into the equation we got in the previous question. And if I do this, I will get minus 2 over 25 equals to 50k times sine 1 minus 0.2. Now I have to solve this equation and find the value of k. I will get minus 2 over 25 equals to 42.07 k. That's when I calculate the value of sine 1. By the way, you have to make sure that you are in radians. Minus 0.2. And when I rearrange this equation, I will find that k equals to 0.000285. That's the answer for that question. For the next question, I will have to find the expression for n in terms of t. And I already know what the value of k is, so I can just substitute it into this first line of question B. And when I do this, I will get minus 2 over square root of n equals to 0.1425 times sine 0.02 t minus 0.2. And now all I have to do is to rearrange this to get n. So I will cross multiply. The square root of n goes here. Now divide both sides by the bracket, and I will get the square root of n equals to minus 2 over the bracket and now to find n, I will have to square both sides. So I'll get 4 over 0.1425 sine 0.02 t minus 0.2 squared. Okay, so that's the first part of the question. We got an expression for n in terms of t. And now we'll have to find the greatest value of n. Okay, how to find the greatest value? I will have to find the maximum of the function n of t. I feel like I'm going to overcomplicate this question because it's just only 2 marks, but I don't really see the other way of finding the maximum apart from looking for the derivative and equating this to 0. So, derivative of n with respect to t is going to be 4 times minus 2 times 0.1425 sine 0.02 t minus 0.2 to the power of negative 3 times 0.1425 times 0.02 t, 0.02 times sine, derivative cosine 0.02 t. Okay, that's it. And now to find the maximum or the minimum, I will have to equate this to 0. Now, 4 times minus 2 doesn't really matter. Okay, next bracket is to the power of minus 3, so it's actually 1 over the bracket. It can never be equal to 0. So that means the only case where we can have the derivative equal to 0 is when 0.1425 times 0.02 cosine 0.02 t is equal to 0. So therefore, that means cosine 0.02 must be equal to 0. Okay, so from here I can find the value of t, or because I have the formula for n which includes the sine of 0.02t, I can just calculate the value of sine using the formula sine squared plus cosine squared equals to 1. And we know that cosine equals to 0. Therefore, that means sine must be equal to 1. So that means the maximum value of n is going to be when the sine of 0.02 t equals to 1. Which is going to be 4 over 0.1425 minus 0.2 squared. And that equals to 1,209.8. And as a final answer, I will state 1,210. The next question is about vectors. And first of all, I'm going to write everything in a parametric form. So vector OA is going to be 1, 5, 6. Then the equation of the line is going to be r equals to 4, 0, 1 plus lambda times minus 1, 2, and 3. And this vector is going to be the direction vector of the line, and that vector OA is going to be vector A. Okay, so now I'm looking for the angle between directions of OA and L. So that means I can use the dot product. So A dot D equals to the magnitude of A times magnitude of D times the cosine angle in between. Okay, so now let's calculate the dot product of 156 dot minus 1, 2, and 3. That's going to be minus 1 plus 10 plus 18. That is 27. Okay, so now the magnitude of A is going to be the square root of 1 plus 25 plus 36, which is the square root of 62. And the magnitude of D is the square root of 1 plus 4 plus 9, which is the square root of 14. And when I substitute all the values into this equation, I will get 27 equals to square root of 62 times the square root of 14 cosine theta. So from here, I can find cosine theta. Then take the inverse cosine, and I will get theta equals to 23.6 degrees, and I will state this as the final answer for this question. To solve the next question, let's start by drawing a sketch. So we have the origin, we've got the point A, so we can draw the vector OA, and also we have the line L. Let's say it goes like that. And we're looking for the position vector of the foot of the perpendicular from A to L. So let's draw a perpendicular from A to L. It's going to look like that. And I'm going to call this point P. So what we're looking for is the vector OP. Now we know that position vector of the point A would be OA equals to 156 And we also know the equation of the line in a parametric form from the previous question. That's here. So r would be equal to 401 plus lambda minus 1, 2, and 3. Okay, so that means vector OP is going to be 4 minus lambda, then 0 plus 2 lambda, which is just 2 lambda, and then 1 plus 3 lambda. Okay, so now from here I can find vector AP. And this vector is going to be equal to AO plus OP, which is minus 1 plus 4 minus lambda, and minus 5 plus 2 lambda, and minus 6 plus 1 plus 3 lambda. And I can simplify this, and it's going to be 3 minus lambda, minus 5 plus 2 lambda, and minus 5 plus 3 lambda. Okay, so now we know that AP must be perpendicular to L. So that means the directional vector dot product with AP must be equal to 0. So AP times directional vector, I'm going to call it L, must be 0. And we can use this equation to find the value of lambda. Okay, so that gives us 3 minus lambda, minus 5 plus 2 lambda, minus 5 plus 3 lambda, dot direction vector of the line is minus 1, 2, and 3. And we know that this must be equal to 0. Let's calculate the dot product. This is going to be minus 3 plus lambda, minus 10 plus 4 lambda, minus 15 plus 9 lambda, and it should be equal to 0. So that gives us equation to find lambda. So we get lambda equals to 2. Now we're looking for the vector OP. It's 4 minus lambda, 2 lambda, and 1 plus 3 lambda. And now we know the value of lambda, which is 2. So that means OP equals to 2, 4, 7. And that's going to be the answer for this question. For the next question, we have to find the reflection of A in L, and I'm going to call this point A asterisk. I've already drawn the diagram. It's going to help us a lot. And we're looking for the vector O A asterisk. Now, how do we get from point O to the point A asterisk? Using the stuff that we already know, which is vector OP and vector OA. From point O, we can go to the point P, and then from P, we can go to the point A asterisk. So that means we'll have to add the vector OP and the vector P asterisk. Now, because A asterisk is the reflection of A, we can see that the vector PA asterisk is the same as the vector AP. Now, we already know the vector OP, so that means the only thing we have to find is the vector AP. How can we get from point A to point P? We can go from the point A to point O, which is going to be the minus vector OA, plus vector OP. Okay, and that brings us to -1, -5, -6, plus 2, 4, and 7. So that means vector AP is going to be 1, -1, and 1. Okay, let's substitute it back, and we get 2, 4, 7, plus 1, -1, and 1. So all in all, we got 3, 3, and 8. That's going to be my final answer. 3, 3, and 8. Next question is about integration, and I'll have to integrate the product of two functions. And whenever I have to do this, chances are that I will have to use integration by parts. And the formula for that is the integral of u derivative v equals to u v minus the integral, and I will have to switch the derivative. So v derivative times u. Now the question is, what's going to be my u derivative and which function is going to be v? Now, because in this formula, I will have to state what the value of u is, and I will have to differentiate v, then u derivative should be easy to integrate, and v should be easy to differentiate. So therefore, u derivative is going to be x squared, and v is going to be natural log x. So that means u is going to be, I will have to take the integral of x squared, which is going to be x cubed over 3, and v derivative is going to be 1 over x. And when I substitute this into the formula for the integration by parts, I will get x cubed log x over 3 minus the integral of x cubed over 3 1 over x dx. And don't forget the limits from 1 to a. Now let's simplify this a little bit, and I will get x cubed log x over 3 minus the integral from 1 to a x squared over 3 dx. Now time to integrate, and I'll get x cubed log x over 3 minus x cubed over 9, and I'll have to substitute the limits from 1 to a. Okay, so now let's substitute the upper limit. I will get a cubed log a over 3 minus a cubed over 9 minus, substitute the lower limit, log 1 is 0, minus 1 over 9, and I will get this a cubed log a over 3 minus a cubed over 9 plus 1 over 9. Okay, now let's have a look at the question, and they tell us that the integral should be equal to 4. So I can make it equal to 4 and rearrange in the form they're asking for. I'm going to multiply both sides of this equation by 9, so I will get 3a cubed log a minus a cubed plus 1 equals to 36. And then I will just keep rearranging this. Okay, now I'm going to factor out a cubed. And finally, I will get a equals to 35 over, divided by the bracket, take the cube root, or the same power of a third, which is exactly what I had to show. Now, the next part is very standard. All I have to do is to substitute a equals to 2.4 and a equals to 2.8 and see if I can get the change of the sign between the left side and the right side. So first of all, let's substitute a equals to 2.4. On the left side, I will get 2.4. And then on the right side, I will get 35 over 3 log 2.4 minus 1 to the power of a third. Now, if I calculate that, I will get 2.4 on the left, of course, and then on the right side, I will get 2.78, and then 2.4 is less than 2.78. Now, if I substitute a equals to 2.8, then on the left side, I will get 2.8, and then on the right side, I will get 35 over 3 log 2.8 minus 1 to the power of a third. Calculate that. And then on the right side, I will get 2.6. Then 2.8 is bigger than 2.6. Okay, so now comparing these two results, we can conclude that somewhere in between 2.4 and 2.8, left side must be equal to the right side. And I will state this as the conclusion for this question. So the change of the inequality sign indicates the presence of the root. Finally, the very last question of this paper. We have to use the iterative formula to determine the solution for the equation. Okay, in the previous question, we found out that the value of a lies in between 2.4 and 2.8. So that means I can start with any number which is in between 2.4 and 2.8. Let's say I'm going to choose 2.6. And then I'll have to substitute this into the right side of the formula. And if I do that, I will get 2.65671. And in the next iteration, it becomes the value of an. Now I'll have to substitute it again. So I will get 2.62668. I will have to continue until I get the same value correct to 2 decimal places. Still not there. Okay, so now finally, we got the same answer correct to 2 decimal places, which equals to 2.64 correct to 2 decimal places. And then I will state this as the final answer for this question. Thank you very much for watching. I hope it was helpful. Bye.